So I'm Brett Henning. I'm with Broadcom, and I'm one of the co-chairs of the SPDM Work Group. And today I'm presenting with Raghu Krishnamurthy from Nvidia and Scott Phuong from Microsoft. And we're going to be talking about the SPDM Authorization spec. So first of all, just a disclaimer, what we're discussing is not in a release standard yet. So this is all preliminary. It may change, and it may change profoundly. So what is authorization, and what are we doing? Well, we're looking at a way to use SPDM as a foundation to build what we're calling authorization, but basically a framework to allow authorized users to perform actions. So these would be protected actions on a device, and we're creating a framework to authorize someone to take those actions. You can think of this as analogous to something like, sudo or logging in as root on a Linux system, right? So you log in, you present your credentials. If you're the right user, you can do something. This can be extended to all kinds of different actions. So this is all coming out of DMTF, so it layers on top of MCTP. Therefore, it pulls in things like PLDM, as well as other SPDM actions and even vendor-defined actions. Expectation is we are planning to get a release of the specification out by the end of the year. There's actually a work-in-progress version that was just released. We actually had to turn in the slides before we put out the spec, but it's out there. You can go grab it off the website. Assumptions. So a couple things that we assumed in this spec. We are building it on top of SPDM, so it's built on top of the 274 spec. We are also leveraging the secure messages framework that we have in SPDM. So both of those are known, and they're tried and true. They've been around for about half a decade now, and we're leveraging them to build authorization on top of them. We will get into a bit about credentials, and then there are some policies as well that'll get mentioned. The actual policies themselves are out of scope for the spec, though, just a heads up. And with that, I will hand it off.
Thanks, Brett. Okay, so at a high level, the spec tries to address a couple of things, right? The first thing is the authorization flow between what we call an authorization initiator and an authorization target, right? And typically you can think of an authorization target as something like a device that's on a platform, and an authorization initiator can be yet another device on the platform, or it can be some off-machine entity, right? And in either case, we want to ensure that authorization is end-to-end secure, right? In general, we assume that the initiator and target are either SPDM requester and responder themselves, or they are proxied via an SPDM requester to an SPDM responder, right? And as Brett already mentioned, we assume that authorization is built on top of SPDM sessions. So we have SPDM sessions between the requester and responder, right? And the main reason to do that is it simplifies the spec significantly, right? And we don't need to reinvent a bunch of stuff like transcript hashes or discovery. Well, we do have discovery, but we don't need to reinvent things like transcript hashes. And we get baseline security from SPDM sessions like confidentiality, integrity, and replay protection. The other thing that we do is we have the specification allows you to authorize any generic message, right? We have no restrictions on what type of messages you can authorize. So it's structured as a thin wrapper around virtually any protocol's message. So the second thing that the spec addresses is credential and the credential policy management, right? To authorize something, you need to have credentials. And for the first version of the spec, we focus on asymmetric key pairs. And the idea is that the public key would live on the authorization target, that's some device on a platform, for example. And then the private key could be on some other device, like a platform root of trust or off-machine entity like a HSM. In the future, we might have other types of credentials that we add to the specification. The next thing is managing credentials and credential policies. We have a standard set of messages that we define to provision these credentials and also associate them with policies, right? Essentially, the credential policy tells what you can use the credential for, right? For example, I want to authorize set certificate from the SPDM or something else, right? Set a sensor or change some other policy on the platform. So as Brett already mentioned, we don't specify policy, we only provide mechanisms. We do have very basic policies that we need to manage the credentials themselves, but beyond that, it's left to users of the spec to define policies. Which button do I press?
Just that. There's a forward one. Oh.
All right. So when we were writing the spec, we really had two usage models in mind. So the first one is just between an SPDM requester and a responder, right? This is the case where I imagine as a platform root of trust on a system that's the requester, and then a responder is the device on which you want to perform some protected action, right? And then the second case, as I mentioned, is an off-machine entity that we have that we've called as user here. So in the first case, the way we address threats is basically to just rely on SPDM sessions that's been around for a while, right? And we don't need to reinvent security for that, right? You already get end-to-end security in that case. In the case of an off-machine entity, we still do have end-to-end security in that, as Scott will show you, we have a challenge response protocol all the way from the user to the authorization target, but we don't specify anything, between the user and the requester, right? But we imagine it to be something like redfish to a BMC, or proxied via redfish from a BMC to a PA route. With that, I'll let Scott get into the gory details.
So how do we do this? As everyone mentioned, we rely on SPDM. So what you see, the first two things you see there at the very top is the session secrets exchange and the session secrets finish. So anyone that's familiar with SPDM, that's just our generic way of establishing, our generic name for establishing an SPDM session. So we have the requester on the right and the responder on, the requester on my left and the responder on my right, which is your left and your right. And the requester is what we in authorization also calls the authorization initiator. And on the right is what we also call an authorization target. But requester and responder is also your typical SPDM requester and your SPDM responder. Now, after establishing a session, we will do the initial handshaking, which is not shown here, where you just set up basic communication protocols like, select your version of communication, get your capabilities. So once that's out of the way, you will then move on towards what we call elevating the session. So in this flow, which is abbreviated USAP flow, which is a user-specific authorization process, the user is an external device is typically an external entity, let's say. It could be a human, it could be your fabric, it could be some service that lives out externally to the requester. But we just call them generically the user. So the user would tell the requester at some point in time after this session is established that, hey, I want to start doing some privilege commands. Whatever those commands are, whatever protocol this is speaking, the user says, hey, I want to do some privilege commands. It tells the requester through some out-of-scope method to say, hey, I'm going to elevate my, my session. So it does that, and per our spec, what that does is it starts to send the start auth Z command, and when that happens, the user provides some credential. So let's say some information such as its credential ID and a nonce. This is how we keep each user, and this is how we keep each user separate, as well as how we ensure that there's no replay attacks, especially after this process returns back to a normal state. But the process essentially is doing sudo, as you would do in Linux. It raises the session. It's more like SU in many respects, because once you elevate that session, then you can start sending these privileged commands. However, what's important to point out is that the authorization target, from the very beginning of the session, or just the very beginning of life for this responder, is always checking incoming requests, and is always asking the question, is the request a privileged request? Is it a request that I need to check whether I need to make sure that, hey, this user has the authority to execute this command, right? But so so we expect that the authorization target, before even the session even gets elevated, to be checking and doing that, because obviously if it's not doing that, then the whole point of authorization sort of falls by the wayside. So if a command requires authorization and we don't have a flow in progress, then the target would be like saying, you're denied, access denied, access denied. But once this process starts, any command that comes in is going to have an extra payload that sits on top of this, that we call it the auth tag here. And that's going to contain credential information, which is going to be, in this case, a signature that's bound to that credential ID. So the authorization target will already have this stored in some user database, sort of say what the credential IDs are, what his public key, what this user's public key is, and be able to validate the command. But every command that comes in during this time frame, that is privileged, would expect an authorized off-tag payload for it to be validated. And this off-tag, as mentioned before, can accompany any protocol. So it's not an SPDM protocol. You know, if you're doing MCDP or PCIe commands, this process provides that framework. Now, so once everything ends, then we expect that the user, again, tells the requester through some means to say, hey, I'm done, so you can now de-escalate the privilege level for me. And that is done through the last two commands that you see, the nOff-Z and the nOff response. So that's, and once that's done, for this particular user, it's done, and everything gets restored to normal. The next flow that we have is what we call the SEEP flow. So this is the SPDM endpoint authorization process. So in this case, we're not really authorizing the user, per se, as we did in our previous flow. We are instead authorizing the SPDM responder itself. And the way we do this is we leverage the mutual authentication that is in SPDM today. And as many of you may already be familiar, that mutual authentication happens, it's not really shown here, it happens in the session secret exchange request and the session, oh, actually it is shown. It's session that right there as you establish the session, that session-based mutual authentication, that's where the SPDM responder authorizes the requester, or actually in this case, it authenticates the requester, preparing for the future commands to come in. So in this flow, again, because we're only authorizing the requester, which in this case could be an actual component or entity. It could be likely a component, a BMC that sits on a board or a NIC, whatever that may be. But we're authorizing that entity itself, and we do that through the initial setup of establishing an SPDM session. But once that happens, your session is essentially escalated from that point in time. Everything is considered, you're considered like you're doing SU forever in Linux. And because of that, we don't, to simplify the complexity, we don't require an authorization auth tag like we did in the previous slide. This makes implementation for simple devices a little easier at the cost of having an always escalated privilege session. But we also help circumvent that by issuing the, actually we circumvent that by adding the elevate privilege command. So at specific times, the SPDM requester can say, hey, I'm going to raise the privilege of the session by just sending the elevate privilege request and response. So it kind of minimizes the window, but the elevate privilege itself isn't really a package that has any additional payload. So depending on your threat model, that could be considered that may or may not be considered a very strong way. But that's why I kind of said that you're really always in an elevated session. But once you issue the elevate privilege level, then any command going through is going to be, again, more tightly scrutinized by the authorization target, because at this point it's going to say, well, if you're issuing a privilege command, I'm going to pass it through. Anything before that, it will just deny it whether you have the privilege or not. And then you can de-escalate, again, de-escalate you through the N elevated privilege request response, which are the last two boxes at the bottom of the screen. And you go back to normal mode, so to speak. Okay, so that's it for the flows, and I hand it back to Raghu.
Okay, so we saw how to use the authorization flows, but for authorization to work, obviously we need to first provision the credentials, right, as we mentioned before. What the spec does is we define 8 persistent credential slots. If folks familiar with SPDM would draw parallels to 8 certificate slots, right? And we say, just for interop, we say that we need 8 persistent credential slots, and then you at least have to use 1, right? And the one that needs to be used is slot 0, that effectively bootstraps authorization, so that needs to be, you can't authorize provisioning of that, right, because you have no credential in there. So you need to provision that in something like a secure manufacturing environment or secure onboarding, right? And that effectively bootstraps authorization in that once you have a key, you can give it privileges to do any other privileged operation, such as provisioning other slots if you so choose, right? And for the other 7 slots, you could either again do it in a trusted environment or use what you provision into slot 0 or slot 1 to further authorize provisioning. Then, as I mentioned before, all credentials are associated with a policy, and it defines what a credential can be used for, and we've got standard messages for it, right? So examples of what a credential can do is, if you sign, let's say we use the user-specific authorization process, you can sign a set certificate command to say that, okay, to authorize that particular message, right? Otherwise, the endpoint would reject it. One of the key points is the spec does not define what a trusted environment is, right? There's no real way to enforce it, but typically it would be something like manufacturing, but if your operations or your threat model allows it to be allows the credentials to be provisioned at a later point in the supply chain, that would work as well, right? And yeah, I think the main thing the spec does is provides you standard commands and responses for you to provision the credentials and their policies. And the last slide is obviously call to action. Yeah, please get involved in developing the authorization specification. We've got a work in progress slides that's up on the website, and as Brett mentioned, we've got the work in progress spec up on the website as well, so you should be able to see all the stuff that you saw today. And you can provide feedback to us, at the link that's specified. And lastly, of course, call to OCP security and Calyptra folks and everybody else to see how we can incorporate the authorization specification, right? So some things that come to mind are DOT, for example, right? Whether it's volatile or DOT being the device ownership transfer, right? And then there are other OCP specs where we are specifying commands for burning fuses, right? So if you could authorize all of those with SPDM, that would be great. And that's all we have.
Thank you very much.